So a quick introduction about me, like I'm working with Orbit Labs for last 2.5 years, and I've worked in different tech stack, including Flutter, web development, Devops, cloud computing, okay, as well as like I have worked in Hadoop and big data and all these technologies as well, right? So let's see how this cloud computing is going to help us. And I can see most of you are somewhere developer. So you are either you are a front end developer or you might be a back end developer, right? Or let's say you are also a mobile app developer, which so here you might be using Flutter as a framework. That's fine. So you are a mobile app developer. The main reason why you guys are doing the programming or why you are doing the coding is that you want whatever idea is being created by the business people. So business people are the one who will came up with some kind of idea, right? They will come. Let's say there's an idea of, for example, Instagram, right? Someone who would have came up with this kind of idea of Instagram or Zomato or Swiggy or Ola, Uber, right? So these are just a simple idea. Now, if we want to take this idea to the end consumer, to the end users, so in that case, we have to first write the program or the code. And this code can be written in different programming languages. We have more than 150 programming languages in this world. You can use any programming language to write the code. And each programming language is made in a way like for doing a mobile app development, you can go for Flutter. Flutter is one of the framework which use Dart as a programming language behind the scene, right? Similarly, for front end development, we have different programming language available. You guys can go ahead with this. Similarly, for backend, you can use Python, Node, and other languages, right? So the main agenda is once your code will be created, okay, you want this code to be reached to your end consumer, okay, or the user who are paying you, right? So here we will have the user. Let's say for Ola or Uber, the user for Ola and Uber is we guys are the user because we wanted to book some taxi. Similarly, for Zomato, we are the user who wanted to buy some food. Okay. Similarly, when you would be working here in the Orbit Labs, let's say you are developing some application. So data scientist would be the user who would be using your application and who would be doing some assessment or some research, right? And for that, we have to first deploy our application somewhere. Okay, where we are going to deploy this application. So they are called as servers, right? So we have to deploy our application. Application means your code, whatever code you have created. Let's say I have created a code in Python. So what I will do, I will have the Python engine here, runtime here. Then I will have Python dependencies here, which my application is using. Then I will put my Python source code here. And once I will put all these things together, then I will run my command, Python app.py command, and my application would be running. And anyone who wanted to use this application, they can come here and they can utilize this application. But here, let's say you have developed some code, but right now your code is present in your local laptop. In your laptop means you have done the development, you have done the coding, and right now you were running your application in your local system at, let's say, 127.0.0.1. That is your local host, right? But now you want to take this application on your servers so that your end consumer, so it could be your users or it could be your consumers or it could be your client, different names we have here, right? So once the code is being created, we want this code to reach to our servers or our users, consumers, or client, and this we will call as deployment because we wanted to deploy this code. And guys, we don't directly deploy the code. Before deploying the code, we have a process to be followed. We first test our code, whether the code you have created, do it have some bugs? If it has some bugs, then you have to resolve that bugs or you have to fix that bugs. Once the bugs is fixed, then we will do. So here there are steps. The first step would be you will test your code, whether your code is working well or not. In the testing, normally we check the algorithm of the code, right? So you would have created some algorithm. Let's say in Python, you would have created some function, right? In the function, you would have created some algorithm here. And this algorithm is also called as your business logic, business logic. These are different terms which you should know while working into different projects. The first term is you should know about like these kind of development that you guys are already aware. The second term is deployment, when we want to take this code from our local laptop, from our local system to the end consumer. Then the third term is servers. Servers are the place where we are going to run our application. What is server? I will again come back here in a minute. Then before deploying the code, because my code might have some bugs, some issues, so I will first test the code. And while doing the testing of the code, I will check my algorithm. And what are algorithm? Algorithm means here you write your business logic. Like we can have an algorithm for a particular use case, right? And in the algorithm, we would have some functions which will be running some for loop, if condition, else condition, all these kind of thing will be there into your function. And we also call them as algorithm, right? So here you will test your algorithm whether it is working and no. Then once this has been done, then we also want you to test whether you have written your code in a best possible manner or not, whether you are following all the standard or not, right? So for each and every programming language which we use in the real world, they have some standard, okay, market standard you can say, which is created by the community people. And while writing the code, we have to follow those standards. Okay, if you don't follow this standard, it might happen that your algorithm is working fine. You are writing the code, your algorithm might be working fine, but your code is not readable. If you will share your code with some other team member, they will not be able to understand your code. Okay, so it is always necessary that whenever you are doing the programming, you have to follow the market standard. Okay, let's say you guys are working in the Python programming language, so you have to follow the standard. Like whenever you are creating or whenever you are defining a variable, you have to use some terms, right? You don't have to give the capital letters here. While creating a function, you have to give the first letter as a small one, and then if let's say the function is add function, so you can give something like that, and then let's say there's one more word is submit. This S would be capital here, right? So different standard which we can follow. You guys can check the documentation. I will share with you. But we also need to check whether you are following all these market standard, as well as whether your code has some security issues or not. It might happen that in your code you have hard coded some password. Okay, you might have some security vulnerability. You are not using the secure mechanism while making a request, right? So again, all these things will come into the second step. The first step is to check the algorithm. Second step is to check the quality of your code. Okay. So here we are checking the exact algorithm, algo, and here we are checking the quality of our we have different tool like SonarQube is one of the tool which we use a lot in this world that will help you to understand and to check the quality of your code. Once SonarQube will give you a green signal that your code is looks fine to me, everything is good, then you guys can go ahead, or you can have some more steps here. You can perform some integration testing and all. Then after doing this, you can go for deployment, where you are going to deploy your application on your server. Now, what are these servers? Servers are nothing, it's like your operating system. So if you have to run any application in this world, okay, we should have an operating system. For example, in my laptop right now, I'm running, for example, Paint here. I'm running this particular Teams application here, some Chrome application here, some Lens or some other application I'm running here. So I need to have the operating system. That's the basic requirement. You should have the operating system. Okay, and operating system could be of different distribution. So you guys can go for Mac, you guys can go for Windows, or you guys can go for Linux. Linux. And guys, whenever we wanted to create the operating system, we need first of all some hardware. Hardware. What are these hardware? It means it is your RAM, it is your CPU, it is your hard disk, it is your network devices like your router, switches. So you need this hardware. Once you have this hardware, then in top of this hardware, you can install your operating system. And once your operating system is ready, now in top of your operating system, you can run your program. Okay, so you can run your program. So I will say it is your program. What is your program? Program could be anything. It might be your VLC media player. It might be your Paint application, Chrome application, okay, Teams application, any application. But in our case, we are going to deploy or we are going to run a program here. That program is this program which you guys have created. Okay, you guys would have created some application, some web application, so you or some mobile application, and you wanted to deploy this. So that would be your program. So you can call it as your program. Okay, you can call it as your program or it is your main application. So the basic requirement we know here is we should have the operating system and we should have the hardware. So we are going step by step. First, you will do the code. You will run it in your local laptop. In your laptop, you might have Windows operating system, and in your laptop, basically you're using a bare metal. So you already have RAM, CPU, and everything in your laptop. That's why you can run here. But now when I wanted to run your application and I wanted to give the access of your application to your end consumer, your client. So in that case, again, I will need some operating system. And when we will have collections of operating system, collection of networking devices, and when we collect them all together, we normally call them as servers. But for now, just for understanding purpose, you can understand like servers are similar to your operating system. When you have multiple operating system, okay, and they are connected with each other via security, via networking, via some storage is connected with them, then collectively we can call it as server. Okay. So server, you should have an operating system. Once you have the operating system, here you can run your Python application, and then you can give the access of this Python application to your end consumer, and they will be able to use your application, whatever you are providing. But we should know, we should have at least basic idea from where this operating system is coming up. So you guys are going to be the developers. So you have to focus mostly in your tech stack, in your programming languages. So we will take some class on like Python or some React on these languages as well. But you should also have a complete overview, like what is going to happen behind the scene. Once you push your code to GitHub or to your Azure DevOps or to some repository, then what exactly is going or is happening after that? That we should know. Okay. So here, in case of operating system, we have three kinds of operating system, as I mentioned. Mac is there, Windows is there, Linux is there. So what should we use in the case of servers? We can use Windows as well here, or Mac as well here, but normally we use and we go for Linux operating system. We go for Linux operating system. And if you have a basic idea or basic overview of Linux operating system, that would be always helpful for you. And why are we using Linux operating system? Okay. The first thing about Linux operating system is that it is open source, right? So if I am using Windows operating system, then Windows is already being created, right? And by Microsoft, and Microsoft haven't given me the source code of Windows operating system. So I can use Windows operating system, but I don't know what is happening behind the scene. And because I don't have the source code, so I can't do much customization as well here, right? But when you wanted to create your own server, in that case, you wanted to do a lot of customization, okay, within your operating system, which would be very hard for you to do it into the Windows or Mac kind of operating system, because you don't have the source code, you don't know how they are working behind the scene, okay, and what exactly they are doing. So it was very hard. Then Linux operating system came up in the picture. There was a guy whose name is Linux to World. He is known as father of Linux. He was the one who built this and made it open source. And because it is open source, so anyone can go and can see the source code of Linux operating system. And guys, in the operating system, you normally have kernel, you have kernel modules, drivers. So you can see how exactly your kernel is working, how exactly your kernel is connected with your RAM or CPU. Okay, how it is transferring the data between your hard disk to, let's say, your RAM. Okay, everything you can see, and if you want, you can modify as well. That's the best part of Linux operating system. So he is the guy who made this Linux operating system, and he's the guy who have also made GitHub. So if you know about Git and Git, so he's the guy who made it, Linux to World. And from his name only, Linux came up. So he had made this operating system open source so that anyone wanted to use this, they can use it without any issues. Okay, so he had this kind of source code which was made by him. And once this source code was made, what different companies did, they took this source code. So they took this open source code, and in top of this, they have installed their own different customization. They have created their own different customization, and they have bundled it together, and they start selling it as their own Linux operating system. And they are called as Linux distributions. So we have a lot of Linux distribution available right now in this world. So you will see we have Red Hat Linux, we have Ubuntu, we have Kali, right? So hundreds of Linux operating system we have. Even if I want, I can create Sudhanshu Linux as well. So what we can do, we can take this source code. In top of this source code, we can do our own customization. We can install our own packages. Okay, whatever customization I want, I will do it. But for that, you should know about the source code. You should know, understand this language. You should know how exactly kernel works. For that, we need a great knowledge of kernels, right? But let's say if you have the kernel knowledge, So you can, in top of this, you can create your own customization, and you can wrap up this, and you can start selling this as your own operating system or your own Linux distribution, right? And you guys can charge for it as well. Let's say I am the one who loves gaming. So what I will do in my source code, I will install all the customization related with gaming. Okay. And once this will be done, I will start selling this as my own operating system. I will say, I will give it any name. Let's say I will give it Sudhanshu operating system. And then I will say, if anyone installs this operating system, he will get the best customization for gaming related things. Okay. Similarly, different company came up, like one is Ubuntu came up, or we have Red Hat as well. Okay, Red Hat as well. So what these people have done, they have created their own customization, and they have started selling it as their own distribution. And the best part is, guys, about Ubuntu or Red Hat, they are built in such a way that they will help you to configure it as your server. Means Ubuntu or Red Hat, you can say, they are giving you some promises. First promise, they are saying that we are very stable. And guys, in case of servers, we need our server to be stable. If my servers are not stable, and in top of my server, or I can say operating system, my application is running. So obviously, if my server itself is not stable, my application will also be not stable, and that will not be a good feedback for the users. That's why we want our operating system to be stable. We don't want that our operating system will keep on getting crashed or these things will be happening. We don't want it, right? So we want a stable operating system. And here, Windows is not that much stable, but Linux is stable. And especially if I talk about Ubuntu or Red Hat, okay, which is normally used for configuring the servers, they are very much stable. And they are saying that we have configured or customized our operating system in such a way that if we wanted to host any kind of servers here, let's say web servers here, okay, or web application here, then we will provide you all the best possible settings. They are providing us. So if like right now we need a server, we need an operating system, because in top of this operating system, I'm going to create one application, and normally this application is going to be our web server. So in that case, we need that operating system which have the best customization for web servers or application or hosting the application. Okay. And then they have a best they have their better community support, and they have been used by different peoples, and as we said, they are used by different companies. That's why we have some of their LTS version, long-term supported version. Means there are some version of Ubuntu or Red Hat or CentOS, Fedora. What they are saying that we have been used by millions of companies, millions of people. So we are a stable operating system. If you wanted to host any kind of server, you can go here and you can learn. You can install this operating system, and you can use it for free of cost. If you want it for practicing purpose, you can use it for free of cost. But if companies wanted to use this operating system, they have to pay some licenses, and they will get some benefit as well from these companies, like customer support and all, and they can use it. Okay. So working directly on this open source Linux operating system was very hard. You should have a good knowledge of kernel, then only you can work here. So what these different companies did, they have made this working on the Linux operating system very easy for us by giving and by providing different kind of customization. Okay. And all these operating systems are similar to each other, but their command might differ. So whatever command we are going to run in Ubuntu, it might not be possible in Red Hat, or vice versa as well. So because whosoever has created this particular operating system, that guy have decided what command they wanted to give. Let's say in my case, I can give my own command. Let's say I will give some orbit kind of command. So whenever someone will run orbit command, something will happen. You guys can create your own command as well, right? So that's why, guys, we come up to operating system, and we decided that we will go with Linux operating system whenever we wanted to talk about servers. So that's why in this world, all the servers which you will see, they are running on the Linux operating system. And they might be using different distributions. Some of them might be using Ubuntu, or some of them might be using Red Hat or Kali, or different distributions available in this world, right? So this is one thing. Now, one more thing which we should know, like whenever we have an operating system, okay, so operating system basic work of operating system is that whenever you wanted to launch any application or service, and this application or service wanted to communicate with your hardware, that is your RAM, your CPU, and your hard disk and everything, your processor and everything. So your program don't know how to directly communicate with the RAM. Your program don't know about this. That's why your program first have to go to your operating system. In the operating system, we have the kernel, and kernel have their its own drivers and modules, and kernel helps this particular programs to reach to the RAM or CPU or the hard disk. You can't directly do it. So if you have the hardware, then cover the hardware, you can't directly run your application. You need some kind of operating system which will be in between your hardware. These are your hardware devices, and this will be in between your hardware and you can say your software or your application. That's what we do. But how can we integrate or we communicate to our operating system? That's again one more question. So let's say we have the operating system. How can I give instruction to our operating system? So normally for giving the instruction to operating system, we have two ways. Either we can go for GUI, okay, graphical user interface, or we can go for CLI, command line interface. Okay. So if you have one operating system, you wanted to give some instruction to this operating system, you can give it via GUI or via CLI. Like for example, right now I'm in Windows, I am giving all the instruction via GUI. I have this GUI, I have mouse, and I can use this mouse, I can click here, and everything is working behind the scene. So guys, whenever I am using my mouse, I'm clicking here or there, it is connecting with my kernel or my operating system, and my operating system is making some decision, and that's why these programs are running or getting closed. So we have two-way GUI or CLI that can be used. Now in Linux operating system as well, whenever we have a Linux operating system also supports GUI and CLI both. So if you have any Linux operating system, you can use GUI and CLI both. But normally in the case of servers, what we do, because GUI is very slow, and GUI have less customization as well. That's why in the case of servers, we normally don't use GUI, we use CLI for making all the instructions. That's why you will see whenever we are in the servers, we normally don't have this kind of GUI. We normally have to write some command, and from the command only we have to interact with our operating system. And guys, in the case of command, we have hundreds and thousands of commands that can be used for interacting to your operating system, to give you some instruction to your operating system, to make some customization, to install the packages. For everything, we have to use command. If you want, you can go for GUI as well, but that can be used for practice purpose and learning purpose. But in the real world, in the real servers, we will normally go for CLI and we will disable GUI because GUI is very slow. Why GUI is very slow? The reason is, guys, whenever you use GUI, like right now I'm using my mouse, whenever I click on any button or whenever I will click on search or I will double click here, behind the scene, this GUI is also connecting to your CLI. I mean, whatever you are doing with your mouse, it is converting that thing into one command, and then it is running running the command. I can say running the command. So whenever you use GUI, basically it looks like you are not running a command here, but for doing everything in the GUIs, there is some command internally. So whenever I will click on this button, minimize button, there will be some command which will get executed. And the best part is I don't have to remember this command because GUI have made one interface for us so that I don't have to remember the command. GUI will convert my action into the command and run it. And that's why here it is very slow. But if you use CLI, then in that case, you can directly give the command and this command can directly be executed. So you will get a faster response. Okay. And GUI takes more space and more RAM as well. That's why we normally disable the GUI. We always use CLI. And guys, these distributions which I have mentioned, they have their own command or set of command. Let's say in Red Hat, if you wanted to install a package or software, we have, let's say, yum command. Similarly, in Ubuntu, we have some apt kind of command. So they might have their different command for doing the same kind of operation or same kind of task. And for that, you have to understand basic command, like how these things works, which I will explain you in future. Basic command, which if you have, then that will always be helpful. Okay. So I hope, guys, it is clear. Whenever we have the code, we wanted to develop the code, we wanted to test the code, we want to check the algorithm of our code, we want to check the quality of our code. If everything is going well, then we will decide to deploy our code. But when we are going to deploy, we need first some operating system or some servers, and this operating system or servers can be created on basis of different operating system. But we are going to use Linux operating system here. And once this Linux operating system can be created, then on top of this Linux operating system, we can install or we can run our program and this program we can give the access to our user. That's the complete story which can be followed. There is some more small steps in between which you will understand as we will proceed further. Okay. Now we have one more question, and the question is from where we are going to get this hardware, because as I mentioned, we need to launch operating system here. And in your case, when you have your own laptop, so you might have a laptop with, let's say, 8 GB of RAM, or let's say 1 TB of hard disk, or let's say with 4-core CPU. So you might have laptop with some kind of hardware, right? And then you can use it. But when we are going to deploy our application on the real servers, so in that case, what kind of hardware should we choose here? Because it will also depend on the number of users. So in your case, if you have a limited users, you can go with the limited hardware. That would work. But if you have billions of users or millions of users, in that case, you have to launch multiple operating system, you have to launch multiple hardware, or you have to create multiple hardware. And from where we are going to get this hardware, it is a very big issue for the companies, right? Like how we are going to get this kind of hardware. The one way is we can go to the market and we can buy this hardware. If we have the money, so we can go to the market and we can say that I need, let's say, 100 TB of hard disk. I need, let's say, 100 GB of RAM. Okay, so I can just give my demand, and accordingly I can buy the hardware, and then I will have to take this hardware and I have to set up this hardware. Setup means you have to connect your RAM with your processor, with your other networking devices. You have to set up your router, switches, NAT gateway. A lot of things you have to switch here. You have to basically connect here, right? So in this case, if you will buy your hardware, then you can buy the hardware. Then you have to set up your own data center, And what are these data centers? So these data centers are the place where we can put our on all of our hardware. We can connect these all the hardware, and they will be working together. And obviously, if you are creating your own data center, so in that case, that company will have to take care of the cooling of this data center, about the upgradation of this data center, about if there's something is breaking in this data center, they have to fix it. So if you are setting up your own data center, then there is a lot of job which you will need to perform, or I can say company will need to perform. So if you will check the picture of very simple data center, you will see how data center looks like. So these are very big hall where you have different devices, okay, and you have optic cables. All of these devices are connected with each other. You have to give electricity supply, okay, because they need electricity supply. You have to provide some cooling as well, okay, and you have to provide some regular update and patches as well. So a lot of things. This is how your data center will look like. But obviously, if I wanted to set up this kind of data center, you can see this is a big data center you will find here. You have to buy the hardware, and for buying the hardware, the company should have the upfront amount. Then only they can invest here. This is also called as investment. They can invest on the hardware, and then we can use this hardware. And top of this hardware, we can run our application, and we can say that I am managing everything. This will be also an example of private cloud. This is also called as private cloud. Why? Because here it is just for you. This data center is just for you or just for your company, and your company is only is going to use it for forever. Right? But here's the problem. Let's say there's a company and they decided to buy 100 TB of hard disk or 100 GB of RAM and all these resources. They have set up their data center, and let's say when they have deployed their application and they got viral. Okay, suddenly they got viral. Let's say if you remember when TikTok was introduced in 2015 or 16, suddenly it got viral. So in that case, if you got viral, so more and more people wanted to use your application. They will keep on hitting your server or your website. In that case, you need more and more hardware. And buying the hardware, like let's say right now, if you have limited hardware, then people or your client will start getting some buffering. Okay, they will not be able to connect your data center. They will get some error. Okay, the server is not responding, and this is not good as per the reliability of the company. This is again one more term, guys, which you should know. What does reliability means? Reliability means like how much we can rely on a application or website. For example, you know about IRCTC. Okay. So Indian Rail, where you can buy some tickets, right? So we can say IRCTC is not reliable because whenever we wanted to hit IRCTC website, normally we have seen it is very slow or it is down, it is not working. Okay, it is in the maintenance mode. That's why we can see IRCTC is not reliable. This is not a good user experience. Okay, your client will not be happy if your website is there and your website is not giving the proper responses and your website is down. Okay, and in that case, no one will love this. That's why what we want to have a good reliability. Let's say Google have a good reliability because whenever you want to hit Google at any time, the Google is there and Google is ready to give you the service. And Google is hardly sometime it will be down. That's why we can say Google and all these Facebook and all these companies are reliable. We can rely on them. Okay, or the client can rely on them. But if you are a company who are very oftenly getting down or server is getting down or crash, then in that case we can say that company is not reliable and it is not good for the company business. People will not or the client will not love to interact with this kind of application or website. So guys, here let's say you got suddenly viral, so you need more hardware. And again, going to the market, buying the hardware, setting up the infrastructure here, it is a time-taking process, right? It is a time-taking process. That's why what companies nowadays do, or a better approach, what they can do, they are saying that there are some companies, like one of the companies, Amazon. We have like one of the companies, let's say Azure, you can say. Then we have Google, which is providing your GCP, right? So what these different companies did, they have the money, so they have already created or built different infrastructure or this kind of data center across the globe. Across the globe, they have already created this kind of data centers. Okay, and they have already set up hardware here. They are already integrated this kind of hardware with the best networking, with the best security compliance. Okay, they have already did all this kind of setup. So all these companies, Amazon, or you can take the example of Microsoft, Google, or even if you know about IBM, Alibaba. So what these companies did, they have the money, so they have invested their money into different part of the globe, different part of this world, and they have already created this kind of data center, and they already have hardware installed or set up, and they already have their team who is keep on checking these hardware health, we can say, right? Now, in that case, what these companies are saying that you don't have to buy this hardware because first of all, when you want to buy this hardware, you have to pay the upfront amount, and not all company can pay the upfront amount. And the second reason is if you got viral, so in that case, it's very hard for you to do the scaling, okay? Because you have to again go and you have to again buy the hardware to set up and everything. So this kind of private cloud is helpful for those companies who are big enough. Okay, so they can go and they can set up their own private cloud. But if I talk about some companies who are startups, okay, and who have a very mid-level audience, so in that case, what they are going to do, they are going to use public cloud, and public cloud have a very simple phenomena, very simple architecture they follow. They are saying that if you don't have the money to set up your own data center, because data center involves a lot of practices to be done. Okay, so in that case, I already have a data center. You can take the hardware on rent. So I can take the hardware on rent, and I will have to only pay for the resources which I have utilized. So I can take the hardware on the rent. The first option was to buy the hardware. The second option is to take the hardware on the rent. It is very similar. Let's say you are someone who wanted to, let's say you are looking for a home or you are looking for a home to stay. So in that case, if you have the money, then you can buy the entire apartment and you can live there. But in that case, you should have the money. And then in that case, if you have buy this apartment, so you will have to take care of about the maintenance of this apartment. If the painting is required, you have to do the paint, or the electricity supply, you have to take care of this. So everything you have to take care. If you are doing if you are buying the apartment, but if you don't have that much money, or if you don't wanted to invest your time on managing these things, so there are different companies. What they are saying that you don't have to buy the apartment, you can take the apartment on rent. And let's say you want to live here for 1 month, so you have to pay only for 1 month. 1 month here, you can pay for that 1 month, and then you can go away from here if you want. And suddenly, let's say you want one more room, so you don't have to buy the entire room. You can take one more room on the rent, and you have to pay for it. And in this case, the company is going to take care about the maintenance and everything of your room and of your apartment. You just have to live here. You just have to utilize this space, and you have to pay for the amount of time you are staying here. Exact same thing we are going to do here. What these companies are saying that we already have this much hardware. We are going to give this hardware on rent. You can take this hardware on the rent, and you have to only pay for the amount of time and amount of usage you are doing. If you have used only 2 GB of RAM, I will only charge you for 2 GB of RAM. If you have used 200 GB of RAM, then I will charge you for 200 GB of RAM. So, so normally this is a better architecture because here you don't have to worry about managing the entire data center. You don't have to worry about buying the hardware or managing the hardware. And here, if you want to get more hardware, let's say suddenly you got viral and you need more hardware, you can just ask Amazon or just ask Azure, GCP or IBM. They will on the fly give you more resources because they already have these resources set up. They just have to allocate that resources into your account, and then you can utilize it. And let's say you have a startup or the company have a startup and they have bought this kind of hardware, and let's say this startup didn't went well. So in that case, they can shut down their startup and they will have to only pay for the amount of time they have used these resources. But in this case, if that company have buy or has created the entire data center and their startup didn't go well, so this is again a liability for them because they have built this data center. It's a liability for them. How will they get their cost back? But here they have to just release the system so that Amazon can give this system to someone else, and you have to pay only for the amount of time you have utilized. So it's a pretty simple architecture that when we use in the public cloud, that's why it is called as public cloud, because anyone publicly can come here and can get the resources, can utilize them and do the things. But here it is a private cloud because it is being set up by you. So you have the 100% authorization on this data center. You can manage anything here. But in case of public cloud, most of the things at the hardware level or behind the scene would be managed by these companies. We can just take them on the run. This is again known as cloud computing. Okay, because whatever computing you want to do, whatever application you wanted to run, we are going to run this on top of some cloud. And this could be private cloud, it could be public cloud, but here we are going with public cloud. That's why, guys, you would have seen normally we use Azure cloud in Unilever, or somewhere you might be seeing that we are using AWS as well. So these are different cloud providers which we can use as per our usage, right? So for example, here we are going to use Azure or AWS. So I will go to Azure, I will create an account in Azure cloud, and then I will ask Azure that can you please create an operating system for me. So in that case, Azure will create one operating system for me. And once operating system is being created, then in top of this operating system, you can run the application which you have built at the first step. So at the first step, you have built one application via some front end, back end code. That application you can deploy on top of this particular operating system. And guys, this operating system is created on somewhere on the AWS cloud or on the Azure cloud. Okay, and then here whatever hardware is required, this hardware is also coming from these companies, and then you can use it, and accordingly you can pay it as well, right? So if you will check any global infrastructure of any of the cloud, so here let's say I was searching for AWS global infrastructure. So you will see AWS have a great global infrastructure. They have already invested a lot, and you can see they have their different at different places. You can see in the India as well. They have in Hyderabad and Mumbai, and they have launched their own region. Region means here they have collection of data centers. They have multiple data centers in Mumbai and in Hyderabad. So if anyone in India, any business is there, they wanted to use AWS cloud and they wanted to get some storage, they wanted to get some database, they wanted to get some computing resources, so they can get it from AWS. AWS have the data center here itself, so we can just get it and we can utilize it. So this investment is already being done by these companies, and we have to just use it, or we just have to ask it, right? That's the basic scenario, guys. What we will be doing. Okay, about the hardware, about the operating system, and about your application. This is the final application which will be running in your operating system that can further use. Now, guys, one more question came up here is, how we are going to create operating system. Okay, how operating system is going to be created. Okay, so how can we create this operating? Anyone wanted to pitch in? Or guys, if you have any doubt till here, you can ask me. And also tell me how this operating system can be created. Now it is clear to us why do we need operating system? Why is clear? Because we know we wanted to run our application and we want to run an application, we need an operating system. And that's why that is the reason why we need an operating system. Okay. And how we will get this operating system? We'll get this operating system from a cloud computing. Here we might be using public cloud. And from this, I will request them to give me some resources and accordingly, I will configure my operating system. But behind the scene, how this operating system will be created, what kind of technology they are going to use to create this operating system. So guys, anyone would like to uh, tell me how this operating system can be created now? Okay, so we have the hardware. So this is being done. We have the hardware. Hardware we have got from, let's say, AWS cloud. They have given us the hardware. Now on top of this hardware, how can I install my operating system? And whether it could be Linux operating system or Windows operating system, but normally we will discuss about Linux operating system. So how can we install this operating system? Okay. So anyone like to mention? No. So yeah, let me then complete this as well. So guys, whenever you wanted to install any operating system in this world, okay, here is your operating system. We have to first get a disk image. Disk image. Okay. In this disk image, we have the entire code of the operating system. Means about entire information about my kernel, my packages, my resources, everything is being about my drivers, and everything is present in a disk image. And what you need to do, you have to just connect this disk image to your system. And once you will connect this disk image to your system, then it will take some time. It will take some 30 minutes or 40 minutes to install your operating system. So if you would have ever installed any operating system in your laptop, you would have seen that normally they have a pen drive. They plug in that pen drive into your laptop, and that pen drive has this disk image, and this disk image might be around 10 to 15 GB of size. So from this disk image, we create or we install the entire operating system. And once entire operating system is being installed, we can remove that pen drive or we can remove the disk image, and then this is being installed in a hard disk. So now onward, you can use your operating system whenever you want. Similarly, here as well, we will need a disk image. Like you guys wanted to install Windows. So in that case, you can search for the Windows disk image, Windows disk image. You will find the Windows ISO file. This is also called as ISO file. So you can come here and you can download the Windows ISO file for Windows 10 or Windows 11. And once you will download it, copy this file into your pen drive and then plug in that pen drive into your laptop. Follow the instruction. You will be able to install the particular Windows operating system in your system, in your laptop, you can say. So we need this image, and all these companies which I have listed above, about all these different Linux distribution, what these people are doing, they are giving you some of your own disk image. So they are giving you some disk image. We can buy this disk image, or we can download this disk image, and we can use this disk image to create the entire operating system. Okay, create the entire operating system. So let's say in top of my hardware, what I will do, or in the case of AWS cloud, what we will do, or Azure cloud, we will buy a laptop. In the laptop, behind the scene, AWS guys will install the operating system for me, and I will be using it. So simple, right? It will take around 30 minutes, and it will take 30 minutes to install the operating system, and then I can use it. Let's say I have more load on my server. So suddenly I have more people wanting to connect to my application or my server. In that case, what I can do, I can go back to my AWS cloud. I can say AWS cloud, I want one more laptop. So AWS guys will create, let's say, one more laptop for you, and on top of that, they will install the operating system. Let's say they are going to do this. But here's the problem, guys. Here's one gap. Like how AWS or Azure are going to provide the operating system to you. So here, if they are using some laptop kind of way, this is also called as bare metal. Bare metal means, let's say they will buy they already have the hardware of, let's say, 2 GB RAM, and then let's say they have the 10 terabyte of hard disk, and let's say they have 4-core CPU or processor. So when you ask for this particular resources, they have given you this resources and they have given you the operating system. Then you have asked for one more operating system. So in that case, what they did, let's say they have attached one more hardware, and here let's say they have 3 GB of RAM they have given, 10 terabyte of hard disk they have given, and let's say 4-core of CPU they have given. Okay, so every time whenever you are asking your AWS or Azure cloud, let's say they are giving you the entire new laptop with all settings. But here there's a problem. The problem is, let's say this operating system is given by AWS cloud, and here you are running your application, and let's say here you are able to utilize around 80% of resources you have utilized, or 90% of resources you have utilized here. Okay, means 90% of your RAM or CPU is being utilized. Means currently it is being loaded. Okay, in this operating system, let's say only 10% of resources is being utilized. Means only 1 GB or let's say 500 MB of RAM is currently in the use, and rest of the 2.5 GB of the RAM is in the free state. Let's say here. But the problem is these are the two operating systems. Here your 90% resources is being utilized, okay, and you need to run some more application here, and that application will need some more RAM, but you don't have much RAM present here. So in that case, what you will have to do, you will have to buy one more, or you have to create one more operating system. And this is very, very hard for us to manage the resources. But because here only 10% of resources is being utilized, so it means 2.5 GB of my RAM is underutilized. Means I am paying for entire 3 GB of RAM, but I am able to utilize only 500 MB of RAM. So this is called as underutilization. Underutilization. I'm not able to utilize 2.5 GB of my RAM, underutilization. And this is a very big problem in the case of servers. Like here you have overutilization, you wanted to get more RAM, but you don't have the space here, but here you have underutilization. So here you are wasting your resources. You are not able to utilize 100% of your resources, and you are wasting electricity and everything. That's why, guys, here one technology came up in the market that have changed the entire picture, and the technology name is virtualization technology. Okay, virtualization technology that will solve this problem. Virtualization technology. What this product technology is saying, that if you have the hardware, now onward, whenever you want to create multiple operating system, you don't need to buy the hardware every time. What you can do, you can set up your hardware one time. Let's say I will set up a hardware of let's say 10 GB of RAM and 100 terabyte of hard disk. That is a one-time process. Now on top of this hardware, you can launch multiple operating systems. Earlier, it was not possible. In top of one hardware, we can have only one operating system. That was the problem. But when this virtualization technology came up in the market, what they are saying is, in top of one hardware, you can launch multiple operating systems. So here I can install, let's say, Windows. Here I can install Linux as well. Let's say here also I will install Linux. Here also I will install Linux. Here also I will install Linux. So in top of one hardware, I can install multiple operating systems. And the best part is, all these operating systems will be independent from each other. Means whatever I am doing here in my RAM, in my this operating system, this will not be visible to other operating systems. Okay, so all of them are independent from each other, and they have solved one problem, one big problem for us, and that problem is called as underutilization. Like in this particular operating system, I was able to utilize 90% of resources. I need more resources, but I don't have. But here I have utilized only 10% of resources. My most of the resources are underutilized. I'm not able to utilize them. But I can't share these resources to this particular operating system. I can't share it. There was no way. But here there is a way. Let's say we have 10 GB of hard disk, so or 10 GB of RAM. So in that case, this operating system can use, let's say, 1 GB of RAM. This can use, let's say, 3 GB of RAM. This can use 1 GB of RAM. This can use 2 GB of RAM. Okay, 3 plus 1, 4, 4 plus 1, 5, 6, 7. Then this can use 3 GB of RAM. Means they can share the resources between themselves. If someone of them wanted to get some more resources, so in that case, I can decrease the resources from this operating system. So it is currently using 3 GB. I will say please use 1 GB because this one need more resources. I can give him 3 GB. So on the fly, this can be done. This is also called as shared resources. We can share the resources between these operating system, and this will solve this underutilization issue which we have. Okay, so I will quickly show you about it. Practically, I will show you in my next session, like how practically you can use virtualization technology. And everywhere you will see we are using cloud. They are using the cloud is built on this virtualization technology. That is the basic of cloud virtualization. Okay, in cloud computing. So virtualization is like a base of the cloud computing. I will show you one good documentation from here. Okay, so like virtualization is a technology that you can use to create virtual representation of server storage. Means it will create some servers for you, but they are also called as virtual representation, virtual servers. I will explain more about it. Here they are saying virtual software mimics the functions of physical software to run multiple virtual machines simultaneously on a single physical machine. That is the USP of this technology, that you can launch multiple virtual machine simultaneously on a single physical machine. Earlier, this was not possible. We have to buy in top of one hardware, only one operating system can be launched. If you want to launch one more hardware on the same or one more operating system on the same hardware, that was not possible. For doing it, you have to buy the entire new hardware, and then on top of this, you can launch the operating system. But when this technology came up in the picture, okay, then it has changed the entire architecture, how the companies using the infrastructure, and they started switching to virtualization, and they are using it. So virtualization is the technology, guys, and then we have a tool named as hypervisor. Okay, there's a tool named as hypervisor. This tool is helping you to hypervisor. Let me write the name first. This tool will help you to utilize the power of virtualization. This is the name of technology. This is the name of technology, and this is the name of tool which uses this technology behind the scene. So we can use hypervisor to create this kind of virtual machines in one hardware. Let me open this. Okay, so you can say by using virtualization, you can interact with any hardware resource with greater flexibility. And physical server consume electricity, take up storage, and need maintenance. Okay, and here they are saying that virtualization will remove all these kind of limitation by abstracting your physical hardware. So now onward, we will install one tool here that will be hypervisor, and hypervisor will be the one who will manage the RAM, CPU, and everything of my all the virtual machine. Okay, and that's what they will do. It will do. So here there's one problem. Yeah, this is the main reason why we are using virtualization. That is efficient hardware usage. With virtualization, the company creates three digital servers or virtual machine on a single physical server. It specifies the operating system requirement for the virtual machine and can use them like the physical server. Okay, so this will help you to use your hardware in a best possible manner. Otherwise, you are facing the issue of underutilization. Okay, underutilization. That's why this will come up in the picture. And if you guys would have heard about infrastructure as service, so behind the scene they use this kind of virtualization technology to give the things for you. And this is the name of tool. It is a software component that manages the multiple virtual machine in a computer. Okay, like for now in my laptop also I have one of the tool available. That tool name is VirtualBox. So what I did, this tool will help me to use this technology. And in top of this tool, what I can do, I can create multiple operating system. Means I have one operating system that is my base operating system, which is Windows. In top of Windows, I can also create here that Linux. I can go to new. I can select what kind of Linux I want to create. You can see they support all Linux, okay, IBM Mac, everything is they are supporting. If I want Linux, in the Linux also they support different Oracle, okay, Fedora, Red Hat. So they Ubuntu, all of them they are supporting. So in top of one hardware, I can have multiple operating system. That is possible from this virtualization technology. And virtualization technology is the base of computer, or I can say this cloud computing. So cloud computing has been originated after virtualization when virtualization came up in the picture. Okay. That's why, guys, whenever you will go to AWS Cloud or Azure Cloud, and you will ask AWS Cloud or Azure Cloud to launch a operating system for me. So behind the scene, what they did or what they do, these companies have already so much money. So they already have the hardware with them. Let's say they might have 100 terabyte of RAM. Okay. in the one of the data centers. They have one data center in Mumbai. They have this much hardware with themselves. So what they are going to do, if you would ask them to launch an operating system for you, so in top of this hardware, they are going to launch an operating system for you. And while launching, they will ask how much resources you want. Let's say I will say I want only 10 GB of RAM, so they will only give you 10 GB of RAM, and you will get it via the virtual technology. It means whenever you use AWS or Azure, they are not buying the entire laptop for you every time. They are not setting up the entire hardware for you every time. Hardware is already there. They just create this virtual machine for them, a virtual representation for them. In the Mumbai region, AWS or Azure Kite might have hundreds and thousands of people. Let's say I am the one who have launched this system. Then here it might happen that you guys are also wanting to launch your operating system here, which is also called as virtual machine in the same region. So here, let's say my operating system is running. I will call it as Sudhanshu. And let's say here someone else, let's say Rohan's operating system is running, and both of us are the client of AWS. So I am also running my operating system here. He is also running his operating system here, but I will never be able to see what he is doing because all these operating systems are independent from each other. All of them are independent from each other. So whenever you are using any of the cloud, so in one cloud they might have their hardware and they might have hundreds and thousands of operating system running. And whenever you will launch your operating system, you will be one of them who will be running your operating system, and no one will be able to see what you are doing here because AWS is taking care of all the security things. So all security related configuration is taken care by AWS or Azure. You don't have to worry. You can just use it. And once your work is done, you can terminate your operating system. And once you will terminate, you will not get any more cost because you have released again version technology. I will explain this technology in more detail in the next session whenever we will have. But this is the basics of cloud computing, which we should know. So if I go back to the first diagram or first story which we have started. So today we have seen all these things theoretically how it works, but in future we will see it practically as well. Like how can we create our code, how can we deploy in servers, how can we get operating system, how can we run some commands, okay, and how the networking things we can set up, security things we can set up. So the basic requirement here would be, or the big picture would be that you guys would be creating some of your code and you will get the instruction from your business team. Business team will gives you some instructions that they want this kind of idea, this kind of application, and you guys will be working in a team. There would be a front-end developer, back-end developer who will work together, and when they will create some code, they will push their code to GitHub or to some Azure Devops or to some centralized repository. Once the code is being pushed here, then we want to take this code to our users because till now you are using your code in your local laptop, but now we wanted to deliver this application to my users. So in that case, we have to deploy this code, but we have to follow here some process. We have to first test our code, check the algorithm, and that is the reason, guys, being a developer, you have to always create your test cases. So in the test cases, you will mention that if I have created an algorithm, let's say the algorithm is the addition add algorithm. So here you are to take you are taking two variables x and y. So what you are returning here, you are returning, let's say, x plus y. This is your algorithm. If you want to check whether your algorithm is working fine or not, so in that case, what you will do, you will call this function from your test cases. I will call this function and I will pass two value 5 and 6. So we know as per the algorithm, it should give 11 as the output. So here we will write some condition to check whether I am getting 11 as the output or not. If you will not get 11 as the output, it means your code might have some bug. Here, instead of using plus, you might have used multiply. There is some bug here that you can resolve. So here we can have collection of test cases that needs to be followed. Then you have to check the quality of your code. We can use SonarQube for that. And once everything is been done, then we will deploy this code on the server. But where we will get the hardware for the server, so we'll get the hardware from the cloud computing or the public cloud. So we will be using Azure cloud or AWS cloud to get the hardware. They will be the one who will give the hardware on the rent, and we have to pay only for the amount of usage we are doing. And once we have this particular hardware, then on top of this, we wanted to launch an operating system. Now, which operating system we will be doing? We have multiple options, but as we discussed today, we will be using Linux operating system because it has more customization, more flexibility. It is more stable, okay, and it's more secure as well. So that's why we will go for Linux operating system, right? And how this business operating system is going to be created. So behind the scene, your AWS or Azure guys are going to use one technology named as virtual technology, and by that technology, they are going to create operating system for it. Once this operating system is created, now in top of this operating system, you can run your application. And once this application has uh, uh, been deployed here, it can be given to your user and consumers, and they can use it. And while doing a deployment, we can use some containers or Docker. What is Docker? We will discuss in our next session whenever we have. So guys, that's all about today.